Okay, so this is your arithmetic sequences and series page, and here are the formulas that you will be given. You will be given the nth term, and you will be given this nth sum. You might have to derive this one, which is just replacing for your a sub n that term so that you get this formula. All right, so if you had to write the formula for the nth term of the sequence, you're going to this first formula, and you're going to keep n as n. A sub 1 is going to be a -3. You're going to find your common difference d by taking one of the terms and subtract the previous term. So we see that the common difference is 7, so 11 minus 4. And then we put it into a formula. So the formula is going to read a sub n equals your a sub 1 plus, I'm going to put the d in front, 7 n minus 1, and n is going to stay generic. So then you're going to distribute your 7. So that's going to give you a -3 plus 7n minus 7, and then you just want to combine like terms. So that's going to give you 7n minus 10, and that would be your nth term. You want to go ahead and simplify combine like terms. Now, if you had to find the sum of the first 30 terms, you're finding a sum. So you go to one of your S formulas, and you want to identify what you have to determine which one you're going to use. Well, I have a sub 1. I know what d is. D is 76 minus 80, so that's a -4. And I don't know a sub n, but I do know that n is going to be 30. So I'm going to use the second second summation formula. So S equals 30 divided by 2, a sub 1 plus your -4 times 30 minus 1. That's plugging everything in. And so then we're going to go ahead and distribute. So this is going to be 1580 minus 120, and then -4 times a -1 is a +4. And so working that out, we get 15 times 80 minus 120 is a -40. -40 plus 4. So getting out my little calculator, so we've got our -40 plus 4 is a -36. So this all becomes -36, and when you multiply that by your 15, you should get a -540. -120, just double checking my work, plus 4. Okay, so that would be your S sub 30. So I guess I forgot a little n on here. There should be an n on the base of these. So that's S sub n, so this is S sub 30. Sorry about that. Okay, now if you're having to find a term, this is also asking you for S sub 30, but in a different format. It's using your sigma notation. So the way to do this, we know this is arithmetic because there's a plus or a minus in it. So to find S sub 30, we are going to use the first formula, but the first formula we need to know what a sub 1 is. So you find a sub 1 by plugging in to the formula, plugging in 1. So let me see this. I wrote that not very well. So we have 4 times 1 minus 1. That's going to give me 3. And then our a sub n is going to be a sub 30. So you find that by plugging in 30. So you have 120 minus 1. So that's going to be 119. And now we can go to our formula, which is n over 2, a sub 1 plus a sub n. And so you're going to have 15 times 122. So 122 times 15 is 1830. And so that would be how you would find the sum given sigma notation. Okay. I already started this problem, and I forgot to hit the record button, so I'm going to kind of back up to explain what I have here. I've circled all the formulas that you'll be given on the test. and then I'm starting in, so these are the geometric sequences and series, and I'm starting in on doing the first problem where you have to find the first three geometric means. So we kind of put out a list. You have your a sub 1 is 4, and then you're going to find these three terms, and now your a sub 5 is going to be 324. So we're using our very first formula. So we have that 324 in blue equals 4 times r to the n minus 1, n being 5. So 5 minus 1 is 4. And now we need to solve for r so we know what to put in those three missing terms. So I'm going to start by dividing by 4. And when you do that, you get 324 divided by 4 is 81. So we want to know what number, and this is kind of like doing your logarithms, write this with a common base. Well, 3 to the 4 is r to the 4, so we know that that common ratio will be 3, and that'll let me fill this in. So just keep multiplying by 3. So this will be 12, this will be 36, and then 36 times 3 would be 108, and that would give us, if you multiply by 3, 324. So you have a built-in check, which is nice. Okay, the second example here, find the fifth sum. That's what sigma notation means. So that means S sub 5 is your A sub 1 is this first term here. Notice it's in the same format. And then times your R is negative 2. Put that in parentheses. And then 5 minus 1. Oh, I'm sorry. Sorry. I'm not using the right, that's a term. I want to use the sum. Okay, so we're going to use our sum formula. Our sum formula says that S sub 5 is A sub 1, which is 3. And then in parentheses, we have 1 minus, your R is the negative 2, put that in parentheses, to the N, because we're using this formula here. So N in this case is 5. It's really important you put that in parentheses, and then we have 1 minus a negative 2 on the bottom. Okay, so working this out step by step, we have 3 on top. 1 minus a negative 2, that does become a plus. So on the bottom we will have a 3. On top, we're going to have 1 minus, and 2 to the 5th is 32, but because it's a negative, it will be a negative 32. And then we can go through and simplify this. So the 3's will cancel, and we end up with a sum of 33. So that would be our fifth sum. Just be careful with the negatives and always put your negative bases in parentheses. Now we get down to our infinite sum, and what you're looking for here is the r less than 1? Because if it is less than 1, you can find the sum with this formula. So in this case, we can find the sum. It's going to be a negative 2 over 1 minus 2/5. So that's going to equal a negative 2 over 3/5, and you would invert and multiply. So that's a negative 10/3, and that would be your sum. If your r is greater than 1, then it diverges and you can't find the sum. Okay, lastly is Pascal's triangle and binomial theorem. You won't be given Pascal's triangle. We would expect you to be able to draw your own, but you will be given the binomial theorem. So if you're going to use the binomial theorem to find the fourth term, remember, k starts at 0. So when you expand this, 1, 2, 3, 4, this is k equals 0, 1, 2, 3. So you're using k equals 3. You're using then n equals whatever the exponent is, which is 8, and it'll look like this. So you're going to go 8, choose 3. That's the same thing as your n over k. A in this case is 2x, so you put it in parentheses. So that's going to be 8 minus 3. And then you're going to put your 3 is just alone, so we don't need the parentheses, raised to the k, which in this case is 3. And then we go through and figure out what that is. So on your calculator, we can do the 8 choose 3 is going to be 56. And times 2 to the 5th is 32, x to the 5th times 27, which is 3 cubed. multiplying all that together, 56 times 32 times 27 gives you a very large number, 48,384 x to the fifth. So the main thing here to remember is if you want the fourth term, the k is going to be one less because k starts at 0. Okay, second one, it wants you to use Pascal's triangle to expand. So x to the fourth. So we're going to have always one more term than what we would be expanding, because again it starts at 0. So we're going to do one term at a time. So we're going to do x to the fourth, x cubed, x squared, x to the 1, x to the 0. Then we do the 3, but it's a negative 3, but to the 0. Then it's negative 3 to the 1, negative 3 squared, negative 3 cubed, so keep the negative, and then negative 3 to the fourth. All right, those are that. Now we need the coefficients. So for the fourth term, you go to the row that has the 4. Notice there are 5 places, and that will give you your coefficients. So there's going to be a 1, there's going to be a plus 4, well, times the negative. Then there's going to be the plus 6. Then there's going to be another 4 goes in here, and then there's going to be a 1. So putting it all together, you're going to have x to the fourth minus 12x cubed plus 54x squared minus 27 times 4 is going to be 108 to the x plus 81. And that would be your final answer.